Alright, so this quick video is just to show you a shortcut on how to multiply binomials when you're raising them to a certain power. So remember, binomial, that's just because this has two terms on the inside. Normally, if you see something written to the fourth, you'd have to write a plus b 4 times, right, in parentheses, and then we just have to distribute that over and over again, which is not impossible or difficult, but that just is a lot of pieces, and this is going to be a shortcut for that. Alright, so the first thing we're going to start with is Pascal's triangle. And it's pretty simple to fill out. The top number is always 1, and the next number, like all the numbers in these, come from the top two numbers added together. So for instance, I'm going to look up and to the left and up and to the right and add those together. Well, nothing plus 1 is 1. Same thing on the other side. All right. Same thing here. Nothing plus 1 is 1. But on this inside, 1 plus 1 is going to give me 2. And then the same thing on this right side. Then I'm going to do that again. 1 plus 1, or sorry, nothing plus 1 is 1. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus, and then nothing plus 1 is 1. All right, so what I want you to do is pause the video real quick. Make sure you see that pattern and see if you can fill out the next 4 rows in this triangle. All right, so that's what I got. Let's just make sure that you have the same thing. You should notice that there's some symmetry on these, right? Like that it increases and then it's going to decrease back down the same way that it started. And so you might be asking, what in the world does this triangle have to do with multiplying binomials? So all of these rows stand for powers. So for instance, if you raise a binomial to the 0th power, it's going to equal 1. Okay, if we raise a binomial to the, so this is going to be to the 1st power, it's going to have this ratio 1 to 1. And what I mean by that is the ratio of A and B. So that's going to be like 1A plus 1B if you raise it to the 1st power. All right, this is to the 2nd power. The next row is to the 3rd, so on and so forth. All right, so this is how my triangle is labeled. So let's go back to this original example that we wanted to look at and see how is this helpful. So we're raising this to the 4th power, so I want you to pay attention to these numbers: 1, 4, 6, 4, 1. All right, so this is just to give you an understanding of, again, what I mean by these are the ratios for each of these expansions. So notice to the 0 power, that gave me 1. That matches that first row. To the 1st power, that gives me 1A plus 1B. To the 2nd power, I have 1, 2, 1 as the coefficients. To the 3rd power, I have that 3rd row, 1, 3, 3, 1. And to the 4th power, I have the 4th row, 1, 4, 6, 4, 1. Now the other thing that we need to pay attention to is what's happening with the exponents. So notice that the exponents on the first term are decreasing until they get to 0. The numbers on the exponents on the second term are increasing. So I've got a squared, then a, and then going from the other direction, starting on the right, I've got b squared and then b. A to the 3rd, a squared a, b to the 3rd, b squared b. Right, notice the same thing on the last one, a to the 4th, a to the 3rd, a squared, a, and then nothing. And then going backwards, b to the 4th, b to the 3rd, b squared, b, and then nothing. All right, so notice that pattern, which you should probably write in your notes somehow. And then the very last pattern that you want to notice is that every term is going to have the same degree. So take this last row, for instance. This is a to the 4th, that's a degree of 4. On this second term, I have 3 a's and a b, that's still a degree of 4. In the middle term, I have a squared, b squared, that's still a degree of 4. On this next term, I have a, b to the 3rd, that's still a degree of 4. And then b to the 4th is a degree of 4. All right, so I have all those notes. Let's do one quick example. All right, so I wanted to show you an example where it's not just a and b, but maybe we've got some numbers in there. So we're going to start by setting up our coefficients or our ratios that we get from the Pascal's triangle. So this is to the 4th power, so I'm going to look at that 4th row. And what I see on that row is that I have, let's see, 1, 4, 6, 4, 1. And I'm leaving myself quite a bit of space in between these numbers for a reason. So I know the first term starts to the 4th power and then it's going to count down. So I'm going to call this times 2x to the 4th. That's really hard to read. And then I'm going to do times 2x to the 3rd, times 2x squared, times 2x, and then nothing. All right, and then I know that this last term starts at the fourth at the end and then counts up going the other direction. So if I do that, I'm going to have times negative 5 to the fourth, times negative 5 to the third, times negative 5 squared, times negative 5, and then nothing on the front term. All right, so now that I have this set up, you can just use your calculator to simplify this. I know it might not look quick, but this is definitely way quicker than having to write that 4 times and distribute that many times. All right, so if I just go through and simplify all of my terms separately, I'm going to get, let's see, this first one is 16x to the fourth. And then the next one, 4 times 2 to the third times negative 5. I'm getting negative 160, x to the third, 160. 6 times 2 squared times negative 5 squared. Make sure you use parentheses in your calculator when you're typing that in. I'm going to get plus, I get a positive number, so plus 600x squared. All right, and this next one, I got minus 1,000 when I did 4 times 2 times negative 5 to the third, x. And then the last one, I think that should be 625. Look at me. All right, that is going to be plus 625. All right, so there you go. That's your shortcut for how to expand binomials when they're raised to a power.